All right, guys, so we are going to start on number 23. So number 23 looks crazy, but we just want to get started right here. So if we are solving this problem right here, the integration of 1 over u is just ln u. And because it has the du, we're going to evaluate from 1 to x. So that will just be ln x minus ln 1. Well, ln 1 is equal to 0, which means it's just equal to ln x. Okay? So if I replace that, then I'm coming down and I'm looking at this problem, 1 over x, ln of x dx. Okay? So I simplified this, found out that the answer was ln x, substituted it back in, and now I'm trying to find this integration. Well, this integration, I'm just going to do u sub. U sub is ln x. The derivative of that is a 1 over x. Now make sure you cross multiply. That means x du is equal to dx. So come over here, 1 over x, and then ln x is just my u. My dx becomes x du. And we can see that the x's cancel. So then we're simply integrating u du, which is u squared over 2. Or, when you replace the u squared, it'd be ln x quantity squared over 2 plus c. So that's how I got the answer of number 23. Okay? Moving on to number 24. 24. We have the problem d dx of the integration of 3 to x cubed t cubed minus 2t dt. Now, when you see this kind of problem where it's asking you for the derivative of the integral, remember the derivative and the integral cancel each other out. So all you're doing is plugging this in. Okay? So that means that it's going to be x cubed to the cubed minus 2x cubed. But you can't forget that you have to multiply that by the derivative of this, which is 3x squared. The reason you have to multiply it by the derivative of that is because it wasn't just x. If it were just x, then it would be fine. We'd just be multiplying by 1, which we don't write down. But since it is something bigger than x, then we have to multiply by the derivative. So this becomes x, 3 to the 3 is the 9th. This is minus 2x cubed. And then you're going to have the multiplication by 3x squared. You could distribute that, but please know that you would have to distribute it. It's not just x to the 9th minus 2x cubed times 3x squared. This would need to be distributed. So you'd either need parentheses or brackets of some sort. On my answer key, I did parentheses. On this one, I did brackets. Both of them distinguish the whole distribution thing, so it's okay. All right, number 25. Number 25 says, when the acceleration of a particle moving along a straight line is given by a of t is equal to 10e to the 2t, they want you to write an expression for velocity if v equals 5 when t equals 0. So they want you to find v of t when v of 0 is equal to 5. So we're going to integrate. We are going to integrate 10e to the 2t dt. That's going to give us velocity. Okay, because you've got acceleration, you're going to integrate to get to velocity. You have a u. Your u is equal to 2t. So du over 2t is 2. So du over 2 is equal to dt. So we're going to come back and substitute this in. We've got 10e to the u, du over 2. Well, the 10 and the 2 reduce to be 5. So 5, the integration of e to the u du is going to equal 5e to the u. Now our u is 2t, and we have a plus c. So that is going to equal v of t. Okay? Now, we said that v of 0 was equal to 5 when t equals 0. Well, e to the 0 is equal to 1, so this is 5 plus c equals 5. subtract your 5, and c equals 0. So you find out that v of t is equal to your 5e to the 2t plus 0. So I don't have to go any further. Okay. So, moving on to the next one. Part B of this same problem says, during the period when the time increases from 5 to 15, how far does the particle travel? Displacement. So that means that we don't care about whether something's positive or negative, we just want displacement. So what we're doing is we want to find how far it travels. Well, you're integrating then velocity. So we need to use part A. We're not going to use acceleration anymore. Because if you integrate acceleration, you're getting to velocity, not how far something traveled. Because remember, acceleration is distance per time squared. This is distance per time. So if we integrate this velocity, we're going to get distance, which is what they're asking for. What's the distance from 5 to 15? So for part B, we are going to integrate from 5 to 15 that velocity function, which was 5e to the 2t dt. Now, just like before, our u is equal to 2t. So we come over here and we put it into our equation. We've got 5 to the 15 of 5e to the u du over 2. So that gives us 5 halves the integration of e to the u du. Or 5 halves e to the u. Now, I'm the kind of person that likes to change these intervals. Okay, so I'm going to make sure and I do that. If t is equal to 5, u is equal to 2 times 5, which would be 10. So down here, this number is going to be 10. If t is equal to 15, u is going to be 2 times 15, which equals 30. So up here is going to be 30. So I have 5 halves e to the 30 minus 5 halves e to the 10. Okay? I can't do anything with that. I don't know what e to the 30 is. I don't know what e to the 10 is. You could pull out a 5 halves, and you could say 5 halves e to the 30 minus e to the 10, but that doesn't really get you anywhere. You still can't do anything with e to the 30 and e to the 10. You cannot subtract those. If I gave you x squared minus x cubed, you couldn't do anything with that. If I gave you 2 squared minus 2 cubed, you couldn't do anything with that unless you actually figured out the numbers, which we're not doing. So we're just leaving that 5 halves e to the 20, or 30, minus 5 halves e to the 10. All right, part C. Part C says, write an expression for the position, s of t, of the particle if s of 0 equals, or s equals 0 when t equals 0. So position of 0 equals 0. Now, you knew your velocity was 5e to the 2t, okay? So essentially what you want to do, your position is equal to the integration of 5e to the 2t dt, which you guys already did, right? You already did it. You knew it was this. So you already know that it's 5 halves e to the u, which was 2t, plus c. That's equal to your position. And so this time, because we are plugging in the numbers, we're just plugging in this, the plus c. So s of 0 equals 0. So you have 5 halves e to the 0 plus c. Well, e to the 0 is 1, so 5 halves plus c equals 0. C is equal to negative 5 halves. So your position, s of t, is 5 halves e to the 2t minus your c minus your 5 halves. So that's how you got part C on number 25. All right, let us look at number 26. Number 26, I can do on this piece of paper, and then I think I have to switch over to something new. So number 26 says, let f of x be a continuous function that is defined for all real numbers, x, and has the following properties. So they're telling you what the integral of 1 to 3 is, and they're telling you what the integral of 1 to 5 is. So then we said find the average value of f of x over the closed interval 1 to 3. So average value, 1 over 3 minus 1, the integration of 1 to 3 of your function, f of x dx. So that is going to be 1/2 the integration from 1 to 3 of f of x dx. Well, that was given to you. They told you that was 5/2. So that means your final answer is 5 over 4. Done. So really, part I was just a matter of, could you plug it into the formula? If you could plug it into the formula, then you were good to go. All right, let's look at part 2. Part 2 says, find the integral from 3 to 5 of 2f of x plus 6 dx. Now, really we need to know how to rewrite this thing. This one can be 2, the integration from 3 to 5 of f of x dx, plus the integration from 3 to 5 of 6 dx. Okay? We're going to have to deal with these separate. Now, how do we find from 3 to 5? Okay? How do we find from 3 to 5? Well, they gave us from 1 to 5, and they gave us from 1 to 3. And if we subtract those, we'll get what we want, which is just 3 to 5. So, the 1 to 5 was equal to 10. The 1 to 3 was equal to 5/2. So when you subtract that, and see I'm kind of running out of paper. Let me bring my paper up here. When we subtract that, this would be 20 over 2. So we have 20 over 2 minus 5 over 2, so that's 15 over 2. 2 times 15 over 2, which is just a 15. Okay? So that's just this portion. Got a 15 right there. So now we got to do this portion. So I'll pull this portion down here. The integration of 6 is 6t. Well, I guess this is x, isn't it? So 6x. And we want to evaluate that from 3 to 5. So it's 6 times 5 minus 6 times 3, or 30 minus 18, which is just 12. And then we had a plus sign in between those. So 15 plus 12 is 27. So that's how we got part 2. All right, part 3. Part 3. Part 3 says, given f of x is equal to a plus b, find the values of a and b. Interesting. So f of x is equal to ax plus b. And I know the integration from 1 to 3 of f of x dx is equal to 5/2. And I know the integration from 1 to 5 of f of x dx is equal to 10. So what I'm going to do is I'm going to use both of these things in order to figure out what's going on. Okay? So if I put this in for f of x, I know the integration from 1 to 3 of ax plus b dx is equal to 5/2. So I'm going to go ahead and get started with this piece right here. The integration of ax is ax squared over 2. The integration of b is bx. And I want to evaluate that from 1 to 3. So I get 9 over 2a plus 3b minus, that's just 1a, so 1 over 2a plus b. All right, so that's 9/2. Well, let's just go ahead and, we'll go ahead and write it. 9/2 a plus 3b minus 1/2 a minus b. That's going to give us, what, 8/2, which is 4a. 3b minus b is a plus of 2b. And we know that that equals 5/2. Okay? All right, craziness. I'm going to do the same thing now with this one. Integration from 1 to 5 of ax plus b dx is equal to 10. Now, my integration is the same. Now, a and b, those are just numbers. I don't know what those numbers are, which is why it stays in a, and it's x squared over 2. It stays b, and it's just x. If I plug a 5 into x, then I've got 25 over 2a plus 5b minus, and I plug a 1 into x, I have 1/2 a plus b. So 25 over 2a plus 5b minus 1/2 a minus b. That will give me, what, 24 over 2? 24 over 2 is 12, so I have 12a. 5b minus b is plus 4b, and I know that that is equal to 10. Now, you've got two equations, and you're trying to solve for two variables. The easiest way to do this without a calculator is linear elimination. What does that mean? Well, that means I want to multiply but one of these by something that's going to cancel out one of the letters. So you could multiply this by a -3 to make this -12. But you'd have to multiply this whole thing. And the reason I don't want to use that one is because if I multiply by a 3, I'm not getting rid of that denominator. So what I would rather do is I'd rather multiply this entire equation by a -2, because then that'll make this -4, which will cancel, but it'll also get rid of that fraction. So the top equation stays the same. The bottom equation becomes -8a, and then we have a minus 4b equals a -5. And now when I combine these together, those b terms cancel out. So I get 4a is equal to 10 minus 5 is 5, and a is equal to 5/4. Now, you can plug this 5/4 into any of these equations. You could plug it into the first equation, or you could plug it into the second equation. It really doesn't matter. If you plug it into the second equation, 4 times 5/4, you're going to get rid of that fraction over there, but you'll have the fraction over here. But this will be 5 plus 2b is equal to 5/2. Subtract your 5. Well, 5/2 minus 5 is really 5/2 minus 10/2. So what's that, a -5/2? And divided by 2, b is going to equal -5/4. So that's how I got both of the answers for there. So part 3, that was a really tough one. That was a really, really tough problem, but it's a really good one to see, because that is a great AP type problem that they could put on a test. Okay. All right, number 27, last one. Number 27, a particle initially at rest moves along the x-axis so that its acceleration at any time t is greater than or equal to 0 is given by a of t is equal to 12t squared minus 4. The position of the particle when t equals 1 is s of 1 equals 3. So find the value of t for which the particle is at rest. Okay, also we have to keep in mind the particle is initially at rest. Okay, so meaning its velocity at 0 is also 0. Sorry, the wind is blowing the door open and shut, so nobody actually came in here. So the particle wasn't moving initially. So when time equaled 0, the particle wasn't going anywhere. And then the position at 1, it was equal to 3. So we're going to use all of this when we're doing our information here. Now, also for part A, it says, when was the particle at rest? And they're talking about other than right here. So you want to find out when v of t is equal to 0. But the problem is we don't know what v of t is. So we're going to find that first. So we want to integrate 12t squared minus 4. So we get 12t cubed over 3. So that's 4t cubed. Minus 4t plus c. That's your velocity. Okay? So we want to try and find that c. So this equals 0 when all of these equals 0. So c is equal to 0. Sweet! So v of t is just 4t cubed minus 4t. And they want to know when this thing was at rest. So we set this equal to 0. Pull out your 4t. T is equal to 0 because 4t is equal to 0. And when t is equal to plus or minus 1. Don't forget that plus or minus 1. We knew this one. This one they gave us right here. This is what we found, plus or minus 1. Now, look up at the beginning. Look up at the beginning. It said anytime when t is greater than or equal to 0. So, in reality, do we care about that minus sign? No. So when time equals 1 is going to be our final answer. Okay? All right, part B. Write an expression for the position of the particle. All right, so part B, position. Well, you're going to integrate velocity. Velocity is 4t cubed minus 4t. That should be dt. 4t to the 4th over 4 is just t to the 4th. Minus 4t squared over 2 is just 2t. Plus c, that's your position. Well, they said that the position was 3 when time equaled 1. So 3 is equal to 1 minus 2 plus c. 3 is equal to minus 1 plus c. 4 is equal to c. So your position function is t to the 4th minus 2t plus 4. Okay. And last but not least, part C. Oh, part C is a doozy. Find the total distance traveled by the particle from 0 to 2. The total distance traveled by the particle. All right, so total distance. Remember, this is a non-calculator thing. So we need to know where is the particle moving left. Okay, where is the particle moving left? Now, we only care from 0 to 2. Now, the reason I put the 1 in is because I know that that's when my particle is stopped and it turns around. It stopped at 0 and it stops at 1. I didn't care about the negative 1 because I'm only going from 0 to 2. I know that I'm caring about velocity right here, and my velocity is this. So if I plug in a half, I have a positive value. Ooh, 1/2 squared is 1/4 minus 1. That's negative. Ooh, I'm going to the left because I'm moving to the left when my velocity is negative. Then if I plug in, say, a 1/2, I'm positive, and then I'm positive again. Because 1/2 squared is bigger than a 1, so this is going to be positive. So I'm moving to the right here. So I'm going to have to take the absolute value of the integration from 0 to 1 of the velocity. And I'm going to have to add it to the integration from 1 to 2. Now, I don't care about the negative of this one because this one's going to be positive. I care about this one because when I do it, I'm going to get a negative answer. Okay? So I want to make sure that I take the absolute value because I want it to be positive. Now, I already know what I get when I integrate this. When I integrate, hold on, 4t cubed over 3. Oh, okay. When I integrate this, I'm going right there. Sorry, I was looking for it. When I integrate it, I get t to the 4th minus 2t, and I want to evaluate this from 0 to 1. Okay? So, when you plug in your 1, you are going to get a 1 minus a 2 minus a 0 minus a 0. So you get a -1 minus a 0 or a -1. I knew I was going to get that, so I have my absolute values there. So that's going to be a +1. Now I integrate this one. I know it's t to the 4th minus 2t, and I'm going from 1 to 2. When I plug in a 2 to the 4th is 16. So I get a 16 minus a 4 minus a 1 minus a 2. So this is going to be 12 minus a -1. Hold on. This should have been squared. Doesn't change this one at all, but it does change this one, because this would be 8. Sorry. And this would then be 8. There we go. 8 minus a -1 is 9. So to get our total distance, we do the absolute value of -1 plus 9, which is 1 plus 9, which equals 10. Okay? Because we moved 1 to the left, and then we moved 9 to the right. So if you add those together, 1 plus 9, you get the 10. Okay? That is it. If you listen to this and you do have a question on it, make sure to ask during class. Remember, your test is not due till Sunday night, so you've got all week to get through this this video and ask questions. And obviously, you don't have to. Well, I guess we're at the end. So if I say you don't have to watch the whole video, you're at the end. You've already have. So anyway, let me know if you have a question, and good luck on your test. All right, thanks. Bye, guys.